Welcome to Easy Alim Learning Simplified. My name is Ruth, and we are going to be discussing on the topic the structure of the atom and the periodic table. And this is a Form 2 topic. Today we are going to be looking at oxidation numbers. Previously, we had an opportunity to look at ion formation, both cations and anions, and we were able to present the charges of those ions. So today we are going to see what is oxidation number and the difference between oxidation number and charges. So we'll look at oxidation numbers, examples of oxidation numbers, and a few examples questions, and then we'll do some questions. First, you start by defining the oxidation number refers to the number of electrons lost or gained. It is usually shown by writing the sign and then followed by the number. So it's the sign first, positive or negative, and then the number of electrons can be 1, 2, 3. And then, for example, atoms that are electrically neutral, they do not have loss or any gain of electrons, they have an oxidation number of 0. Most of the time, it's not indicated in the atom, especially the neutral atoms. However, if they react by gaining or losing, they acquire a new state. This is what we refer to as the oxidation number. Let's look at the following examples. So we have sodium that has an electronic configuration of 2.8.1. It has an ion formula of plus. This plus tells us that it has lost one electron. So the new configuration is going to be 2.8, 2.8. It has lost this one electron. Then the oxidation number now, we said it is a charge, so it is positive, and the number of electrons it has lost or gained. In this case, it has lost one, so we put the number, the number. Magnesium configuration is 2.8.2. It loses 2 electrons from this formula, so the new ionic configuration becomes 2.8. So the oxidation number is a positive or negative, so in this case it's positive, and then 2. Aluminium is 2.8.3, and you can see it has 3 electrons in the outermost shell that are lost. That's why we have a positive. So the new configuration becomes 2.8 as well. So the oxidation number is positive, then the number of electrons. Nitrogen is 2.5. So you can see from the formula it's gaining, because of the negative, it's gaining 3 electrons. So the new configuration is 2 and 8 because it gained 3 electrons to be 8 on the outermost shell. So that the oxidation number will become negative, and then we put the number. Sulfur is atomic number 16. The configuration is 2.8.6. Looking at the formula, it tells us it has gained 2 electrons. So the new configuration is 2.8.8. So the oxidation number is going to be negative and then 2, the number of electrons it had gained. Then chlorine is 2.8.7. So you can see the negative tells you it has gained 1 electron. So the new ionic configuration becomes 2.8.8. So the oxidation number becomes -1. So you see some elements usually have more than one oxidation state. They usually say that it has variable oxidation state. And this oxidation number is usually indicated in numeral and is placed in an equation in the brackets. For example, when we talk about copper 1, this 1 in brackets means it's the oxidation number of copper, which is +1. If we talk about copper 2, it means copper in this case has the oxidation of +2. So this becomes +1, this becomes +2. And then when we look at iron 2, maybe in the case of iron 2 sulfide, this 2 indicates the oxidation of iron, which is positive 2. And then another example is iron 3. In the case of iron 3 chloride, this 3 is the oxidation of iron and it becomes positive 3. And then another example is sulfur 6 oxide. Sulfur 4 oxide. So the oxidation number of sulfur in this is positive 4. And finally, sulfur 6, in sulfur 6 oxide, the oxidation number of sulfur is positive 6. So those examples are further shown. You can see copper has 2 oxidation, both positive 1, positive 2. Iron also has 2 oxidation numbers, positive 2, positive 3. Lead has positive 2, positive 3. Manganese has positive 2 and positive 7. Chromium has positive 3 and positive 6. Sulfur has positive 4, positive 6, and carbon has positive 2 and positive 4. There are other also transition metals we didn't discuss. They also have varied oxidation numbers. So what is the difference between the oxidation number and charge? So the oxidation number, the charge is written before the number. And then in the charge, the positive or negative is written after the number. For example, you can see it happens a lot when we are showing the notation. So you see magnesium is 2 plus, 3 plus, 1 plus, 1 minus. It's the number first, then the charge. For the oxidation number, is the charge or the plus minus and then the number. That is the big difference between the two. So looking at a few questions, what is the oxidation number of the following ions? Copper 1 ion, so the oxidation number becomes plus 1. Lead 2 ion, the oxidation number of lead 2 ion becomes plus 2. Bromide ion, the oxidation number becomes minus 1. Aluminium ion, the oxidation number becomes plus 3. And sulfide ion, the oxidation number becomes minus 2. So that brings us to the end of the session. I hope you have been able to see the difference between oxidation numbers and charges, and you can be able to distinctively give examples if you are told so. And especially when it comes to the transitional elements, I hope you have been able to see how we can derive the oxidation number from the numbers given in brackets. That brings us to the end. So for the next session, we'll be looking at valency, and we're also going to look at the valency of the 20 elements and also on the transitional elements.